In this video, we are going to see definition for the pumping lemma of context-free languages. In the first section, when we completed regular languages, at that time we had seen pumping lemma for regular languages, if you remember. Similarly, we also have a property for context-free languages, that is pumping lemma for context-free languages. Pumping lemma for context-free languages. So let us define this property and understand the meaning of the notation. Let us assume that L is a context-free language. Then there is an integer n, and there is an integer n, so that for any string that belongs to that language, satisfying the constraint that the length of that string is greater than or equal to n, there are the substrings of this strings u in the form of v, w, x, y and z that satisfies the following equation, that u is equal to v, w, x, y, z. Length of wy is greater than 0, length of wxy is less than or equal to n. Then for any m greater than or equal to 0, v w raised to m, x y raised to m, z also belongs to that language. So we have seen the pumping lemma definition of regular languages. In that we had seen the string x which belongs to that language, which satisfies the equation length of x is greater than or equal to n. There are substrings for that x in the form of uvw, if you remember, right? In that case, length of uv was less than or equal to n, whereas length of v was greater than 0, and for any powers of m we had to check the power of v. If we keep on increasing the power of v, the generated strings also should be part of n. Similarly, here in case of a context-free language, we divide our string in the form of 5 component, that is v, w, x, y, z. Our string is here referred as u, such that length of wy is greater than 0. So either w should have one symbol or y should have at least one symbol in this case, right? Then only length of wy will be greater than 0. So the component of k that we used to take, that is greater than or equal to 1 here, gets applicable either to w or to y, correct? So what we can do is, suppose if we want to prove, suppose there is a problem to be solved, that suppose we have to prove that a raised to n, b raised to n and c raised to n, where n is say greater than or equal to 1. We have to prove whether this language is not a context-free language. Okay, so we'll do this with help of proof by contradiction, similar to that of what we did with pumping lemma of regular language, right? So we'll do it with help of proof by contradiction. We'll assume in this language that this language is a context-free language, and if this language is a context-free language, then it should fulfill the pumping lemma for context-free language. So in this case, what we will do is, we will assume here that since the length of wxy is less than or equal to n, the string wxy can contain at most 2 distinct types of symbols from a's, b's and c's, right? What we have to do is, we have to assume that w, x and y, these 3 components are comprising of at most 2 distinct type of symbols from a's, b's and c's. So either you can take ab's or you can take bc's. So 2 distinct type of symbols should come in your w, x and y. Now we also know that the length of wy is greater than 0. Now if the length of w and y is greater than 0, w and y together contain at least one symbol. So either w should be greater than or equal to 1, or the y's power should be greater than or equal to 1. So in this case, the string v, w square, x, y square and z will contain additional occurrences of symbols that will be present in w and y. What will happen due to this? As we have seen in regular language also, if we take multiple powers like power of 2, power of 3 further for w and y, we will be getting additional symbols in those components. Okay, So but that will contradict, because that will not be our strings from that language, so that will contradict, so that will contradict our assumption itself. And by proof by contradiction method we can say that this particular language is not a context free language, right? So what I would do is I would recommend students now to look at this particular video and also recall how we had solved regular language pumping lemma, and based on the guidance given in this video you all advised to complete the proof for this particular problem, right? So you have to solve how a raised to n, b raised to n, c raised to n greater than equal to 1 is not a context free language. Okay, so this you have to solve by proof by contradiction. Okay, that is your next assignment.